So here I'm going to try to answer the question, what is evolution? If you want kind of a fun music video to kind of watch, while it may not be 100% scientifically accurate, Right Here, Right Now by Fatboy Slim is something you can take a look at. They kind of show in that particular music video process of evolution. So starting with, what is evolution? Well, it's a change over time building on past and current features. So products evolve, knowledge evolves, and beliefs can evolve as well. So don't think it's just any one thing. The example here clearly of the phones and how they have evolved. Within the mobile phone industry, also the changing that has occurred. So within our evolution, it's the mark of an educated mind to be able to entertain a thought without accepting it. Because I know this can be a highly debated or contested topic, so just keep that in mind as well. Evolutionary patterns in biology have been noted as far back as Aristotle. There's one of his quotes there in the BC era. Darwin initially used the phrase descent with modification to explain the concept of evolution. Now, what is evolution? We're looking at these patterns of evolution have been observed in three major areas: fossil records, anatomical features, and molecular distances. So our fossil records, finding them in different layers, how things may have changed, again, over time, the different layers of rock. Anatomical features, what similarities we may see that exist that may show a progression. And molecular distances, looking at our DNA and what similarities may exist there as well. So we're looking at the fossil records in a little bit more detail. There's the evolution of a horse here, provides the most direct evidence for macroevolution. Fossils are preserved, remain tracks and traces of once living organisms. They're formed when organisms become buried in sediment and calcium in hard surfaces and are mineralized. Array of fossils according to age have often been provided as successive evolutionary change. Here we're seeing the development of what was once kind of many toes here to kind of that one central hoof of a modern horse. Array of fossils according to age provides evidence of successive evolutionary change. We can kind of see that over a long period of time here. We can also see consistencies. So here we see different rock layers, and we're seeing consistencies over a period of time as well. So we're seeing things progress. We're seeing things found in the same layer at different regions, indicating that they existed over multiple areas, all during the same time. This kind of shows also the kind of formation of where things may have existed and went extinct at certain points as well. Within our fossil records, you get very detailed. Fossils have been found linking all major groups. The forms of linking mammals to reptiles is particularly well known. You can see the high degree of specificity that occurs here and how we can trace things back to common ancestors and group things as similar species or similar related species as well. So all things to consider here. And it can get very, very complex. Looking at kind of one brief example here is looking at the kind of the whale and kind of going back and where that may have come from. Well, when we're kind of looking at this whale evolution, looking at it may once have derived from organisms that once had legs, may have been land-based as well. Looking at the cow and the hippo here, kind of having distant relationships. And some of the progression and how things don't necessarily always get necessarily more complex with evolution. They just are better fitting to their environment. Now the anatomical records, looking specifically, there's a little cartoon representation here, but all vertebrates share a set of developmental instructions. These kind of, this fish, this reptile, this bird, and this human all kind of look the same. If I didn't put the kind of titles here, indicating that there may be some similarities that may have occurred because they all look the same starting very early on. Now, if you look at the kind of the actual images, you can see kind of the same pattern: the reptile, the bird, and the human here. Very hard to distinguish the two from a very early on, indicating that they may have some sort of connection early on to some sort of similar species. We talk about homology and homologous structures. These are similar anatomically, but have different functions. They have different structure and function, but are all derived from the same part of a common ancestor. Common ancestor possesses this 1-2-5 structure as example presented here. Adaptations to different environments with modified its structure in several ways. We see that here where we're having the same anatomy, the same bones, but very different functions. The human, the cat, the whale, and the bat, well, they have the same bones, but the human's using it for grabbing, the cat's using it for walking, the whale for swimming, and the bat for flying. Analogous structures, in comparison, have similar features and functions. They resemble each other as a result of a parallel evolutionary adaptation. So here we have a fish, we have a bird, we have a mammal, and they have these very similar or analogous kind of structures, all used for swimming. But if you notice that the bone structures are different, but they've kind of reached the same end structure to be able to best meet the challenges of their environment. Now, that quick comparison of analogous and homologous structures, again, it kind of puts those two parts together. Same bones, different functions, different bones, same function. This also groups them as well. We see here analogous structures all used for swimming. They have a different structure but similar function. Here we have similar structure but different function as well. Just another way to present the same information. So we're looking at convergent evolution. There's many paths to one goal. So we have convergent and divergent. So divergent may be easier to initially understand, where we have a vertebrae and we're separating out into two distinctive paths. For example, this branch on the left is going to produce gills, and this branch on the right is going to produce lungs. Now when we have convergent evolutions, while we had this separation, now we have the shark and the dolphin. They're both living in an aquatic environment. While one may have gills and one may have lungs, they are starting to develop that streamlined appearance. They're starting to develop those fins. They're having that convergent evolution. They're kind of coming back and having very similar features despite being separated out, one having lungs again and one having gills. Analogous structures are a result of convergent evolution. Different animals often adapt in similar fashion when challenges by similar opportunities exist. And we can see that with different animals living in different parts of the world, developing very similar structures to meet the challenges of very similar environments.